All right, so what are these new row wops? What is this new set of rules? And they're not as shocking as one might imagine. There's only really 3 row wops that we're ever allowed to do in a matrix, at this moment at least. And they are interchange 2 rows, multiply a row by a non-zero number, and multiply a row by a non-zero number, and then add the product to any other row. Now there is a set of notation, set of symbols that indicate what we are physically doing in each row. So for starters, we just have to accept, or at least understand, that in a given matrix we have row 1, row 2, and row 3. And so in this particular notation it says we're going to swap row 1 with row 3. So what I'm going to do then is I'm going to do that operation. And again, why we're doing that, well, we'll get to the whys and what the motivating factor is here in a moment. But right now, it's what does this mean when we decide that that's the row op that we want. So swapping row 1 with row 3 means row 3 is going to now bump up to row 1, and row 1 is going to go down to row 3. I made no statement or rule about row 2, so row 2 is just going to copy itself over. It's just going to go right over and just sit there. Okay. Our second row op is we are allowed to multiply a row by a non-zero number. So in other words, you can't multiply by 0, but you can multiply by anything else you want. So 2 times row 3, well, row 1 and row 2 I didn't touch. So I'm just going to copy those guys over. Now row 3, I'm saying that I'm going to multiply each number by 2 and then put that right back. So I want 2 times 3, which is 6. 2 times 1, which is 2. 2 times -1, which is -2. And then 2 times 9, which is 18. Okay. The third row op involves multiplying and then adding something together. So in this case, I've got a rule, and again this says that's the rule that I'm going to follow, and that's where I'm going to place it. So I'm going to add row 1 to row 2 and then replace it into row 2. Here I'm going to multiply -6 times row 1 and add that to row 3 and then replace that with row 3. So notice I don't have any rule that has changed row 1. So row 1 I am just going to copy over. And now what I want to do is I want to fill in these blanks based on the formula or the row op that I've come up with. So when we said row 1 plus row 2, so I'm going to go into there, I'm just going to add them up. 1 plus -1 equals 0. So that's the number that goes there. 2 plus -1 is 1. -1 plus 3 is 2. And 0 plus 3 is 3. Okay. Then the other row op that we see there. So we say -6 times row 1 plus row 3. And so that one you can do in your head. If you need to type it out in a calculator, you're more than welcome to. So that one gives us 0. Then I got -6 times 2 plus row 2. Sorry, row 3, sorry. -6 times 2 plus 2. Again, that first 2, this might help if I show you where I'm getting these numbers from. Alright, so that first 2 I got from there. That second 2 I got from there. Anyway, so what is that? That would be -10. Then I get -6 times -1 plus -2. And -6 times -1. So that's 6 minus 2, which is 4. And then lastly, so -6 times 0 plus 18 should just be 18. And so sometimes you actually do need to write it out instead of trying to mentally do all those multiplies and adds in your heads. But that's our third and final row op that we're allowed to do. Okay, so this brings us to why we want to pick certain row ops over others. What's our goal? How do we transform the original augmented matrix into that row echelon matrix? And so we end up using this process called Gauss-Jordan Elimination. And the way that process works is we start right up in this first case to get a 1 in the upper right-hand corner. So we try to get a 1 there. Now I'm a lazy guy, and I'm going to try to get, looking back at our 3 row ops, let me kind of put those back up on the screen before we move on here. Looking at those 3 row ops, which one's the easiest one to do? And that's row swap. So if I can accomplish anything using a row swap without messing up something I've already done, then typically I'll do that. Second thing is that second row op where I'm going to multiply by a number. So if I can think of a number that'll get a 1 there, then I'll do that. And the last case is to multiply and add. Well, that's the most amount of work. So you will have to use that one, but typically not to start off with getting that 1 in that corner. So my first goal is to get a 1, and I'm going to try to do a row swap first. And if I can't find one that'll work, then I'll multiply by something. And at that point, I should be able to get a 1 there. Then my next goal is right here. I want to get zeros right underneath the 1. So I'm going to pick the linear combinations one. So that third row op, go back up here. This guy right here, this multiply and add, is going to be your row op that'll put zeros underneath the 1s. So once I've got the first column done, then I go to the second column. Do the same thing. If I can row swap it, great. And if not, then multiplier by something to get a 1 there. Then I do the 0, and then I do the 1. Okay. So at any stage of our process, if you're not sure what you're trying to do next, look back at this chart and see, well, what do I have? Do I have a 1 yet? Okay, no. Then I need to get a 1. Or do I have a 1? I do. Okay, so then I need to get zeros underneath it. And then we're going to keep going until we get that row echelon form, and then we'll revert back to the system form and then try to use back substitution on that. Okay, are we ready? We're going to try one. Okay, so here's our first system of equations, and our very first task is to put it into augmented form. So that would be 3, 1, -1, 9, and already I'm making assumptions about space. Let me get a little bit more space there. Then -1, -1, 3, and 3, and 1, 2, -1, and 0. Okay. All right, so my first goal is what? It's to get a 1 in that first column in the upper corner. I got a 1 in the bottom corner. So is there a row op that'll very easily get a 1 up there? Yeah, just do a row swap. So if I row swap 1, row 1 with row 3, then I should have a 1 in that top corner, and at least I got one of my first goals done, right? Okay, so that gives me as a result 1, 2, -1, 0, and I didn't mess with row 2, and that puts that top row down at the bottom. Okay, so now what? Well, I'll bring this up here. So now my goal is to get zeros underneath that 1, right? So the way I'm going to do that, let's see. So if I look at row 1 and row 2, if I just add row 1 to row 2 and swap that in for row 2, that should put a 0 there. And let's look at row 3. Is there something I can multiply 1 by to get it to cancel out with 3? Yeah, how about negative 3? So if I go negative 3 times row 1 plus row 3, then I can put that in for row 3. Okay, so that's what my goal is. Let's see, I'm going to leave some space to write just in case we need it. So who did I not mess with? I didn't mess with row 1. So row 1, I'm just going to copy over. Row 1 plus row 2. So that would be 1 plus negative 1, which is 0. So I got a 0 there, which is good. That's kind of why I made that decision. But then I have to go through and add all the other row 1s and row 2s. So 2 plus negative 1, which is 1. Negative 1 plus 3, which is 2. And then I have 0 plus 3, so 0 plus 3, which is 3. Okay, so that wasn't too bad. And that takes care of row 2. All right, then we got row 3. So we have the negative 3 times row 1 plus row 3. So negative 3, you know what, I'm just going to write this out. I know there's 4 of these, so I'm just going to write them out ahead of time. And let's see, I want row 1. So row 1 is 1, 2, negative 1, and 0. And then I want row 3 that I'm adding that to. So that would be 3, 1, negative 1, and 9. Okay, so at that point then, it's just a matter of working out the little tiny multiplies and adds. So that gives me a 0 there, so 0 there. Let's see, negative 6 plus 1 is negative 5. So that'd be 3 minus 1, which is 2. And that would just give me 9. Okay. All right, so let's think about our goal, and then we'll think about what the row wop should be. So let me kind of scroll back up here. So we got a 1 in the top column. I got 1s underneath. Next is to get a 1 in the middle. Let's go down. Hey, there's a 1 in the middle. Awesome. Okay, so that part's done for us. Now I need to get a 0 underneath. Well, anytime I want a 0, that means I'm going to multiply and add to something. So I'm going to look at the 1 that I just got. What can I multiply 1 by to get it to cancel out with negative 5? And that's just 5. So if I do 5 times row 2 and add that to row 3, and then do substitution for row 3. Okay, well, who did I not mess with? I didn't mess with row 1 or 2. So I am just going to bring those guys over. All right, so I know I got 4 sets of these. Don't really need parentheses there. So I'm just going to set this up. And just to clarify, I should be looking back at the previous matrix. Should be looking at this one right here as far as getting my numbers from. So row 2 is the 0, 1, 2, and 3. And row 3 is 0, negative 5, 2, and 9. All right, so then I want to simplify that all out. All right, so that gives me 0 for the first one, 0 for the second one, which is good. That was the whole reason why I showed up and did that. Then I get, 10, 10 plus 2, which is 12. And I get, 15 plus 9, which is 24. Okay, so now what is my goal? It's going to go back up here. So I got the 0 underneath. Now I want to get the 1. Okay, so I'll come back down. Is there something that I can do to 12 to get it to say 1? And I know it's multiply, but let's just kind of think out loud for a second. Is there something I can divide by? Yeah, divide by 12. Well, is there something that means the same as divide by 12, but it's in terms of multiply? And that's where this reciprocal comes in. So I'm going to multiply row 3 by 1/12, and then do a row swap for it. Now, row 1's and row 2 didn't change at all. And row 3, all right, so I got 1/12 times 0, which is 0. So, and that actually shows up twice. I got 1/12 times 12. Okay, well, that's just 12 over 12. That's just 1, which is the whole reason why I did this. And then I have 1/12 times 24. Well, 12 goes into 24 twice, so it's just 2 times 1, which is 2. Okay, so what do I know? Yay, we are done with the matrix part, but we're not done with our solution. So take a deep breath. This definitely requires a little bit of patience to get it to work out for us. But I do know something, right? What does that 1 tell me? That tells me that z has to equal 2. Okay, so now we're going to use back substitution. So that row that says, the middle row says 0, 1, 2, 3. So that says y plus 2 times z equals 3. And I know z happens to be 2. And I'm having color issues. Okay, so that's y plus 4 equals 3. So y has to be -1. And then I got that top one, the top row, that says 1, 2, -1, 0. So that's x plus 2y minus z equals 0. So x plus 2 times -1 minus 2 equals 0. What is that? -2 minus 2. So x minus 4. So x is 4. Okay, so last but not least, actually put it in its ordered pair form, and then we have an answer. So 4, -1, and 2. Now, this does require a lot of patience, and if you can do a lot of the adds and multiplies in your head, you'll actually find that this is a very quick method. A little bit quicker, but the problem being a lot of students need to write it out or type it in a calculator, so that's why it ends up taking longer. But anyway, so there's one. We're going to do another one here in a second.